So I think I'll start with this quote that says, the best agent isn't the most advanced one. It's the one that clearly solves your problem. So let's take, for example, let's say you have a problem. Maybe you need to get to, from Enugu, like from this blockchain hub, you need to get to New Haven. Are you going to get on a jet to get to that place? No, because there are other easier options, right? Like taking a bus, a keke, shuttle, a boat, than taking drastic actions to like get on an airplane or a jet. So that's basically what we're trying to explain. So does any one of us here know what an LLM is? Anybody? Okay, let's go to the next slide. So since nobody here knows, I'll give my own definition. LLMs means literally lights making stuff up. So I'm going to be making lots of stuff up for you guys here today, and I hope you enjoy it. This is the next one. So if we're talking about LLMs in simple form or a very simple explanation, LLMs are basically machines or artificial intelligence systems that are trained on vast amounts of text and code. So a way I'll put this is a basic example is ChatGPT actually. ChatGPT is an LLM, and ChatGPT has been trained on vast amounts of text and codes that when we ask it certain questions like, oh, what can I eat? I'm based in Nigeria, Enugu. Can you give me food suggestions? Or can you give me, curate a food plan meal? ChatGPT has been trained with data from lots of places, including Nigeria, even down to Enugu, that it can give you curated, suggestions. Okay, you can eat oppa. Enugu is best known for like oppa and the rest. You can eat that, or it can give you other suggestions like beans or moi moi and pap for your breakfast options. That's basically what an LLM is. So there are neural networks that are trained on massive text plus code. They learn patterns, structures in this text, so that when users give them an input or a prompt, they are able to, they'll check the structure, check the pattern, and see the one that matches best and give you a response based on that. So they predict the next word with intelligence through assigning probabilities to all possible words and tokens, and they can reason and follow instruction. Next slide, please. So if we've at least come to a good understanding of what LLMs are, we just look at LLMs as the brain. Now you ask yourself, what's an AI agent? So for me, I would say if LLM is the brain, an AI agent is actually, the service worker that does the actual stuff, right? An agent is what you get when you give an LLM structure, goals, and sometimes tools. I think a basic example would be, let's say, asking ChatGPT to maybe get you the weather condition of a state in America, right? Now, we've given ChatGPT that tool. It can search the browser or search the internet or, use the necessary weather API tools to get you that information. That's what an AI agent is. So, there are systems powered by an LLM. Every AI agent has an LLM as the brain or as its intelligence. They analyze situations and make decisions, and they use tools when needed. So if they need to go, query an API or search for something on the browser or use an external tool to get you your results, they will do that. That's the difference between an AI agent and an LLM. An LLM will just basically give you text responses, right? Because they've been trained with vast amounts of text. So whatever it is they will give you is based on what they've been trained on. One AI agent can go the extra mile of, using tools to get you your results or your information that you read. Okay, so I'll pass the mic to Elliot so that he can explain what an agentic workflow looks like.
Okay, so traditionally or prior to the coming of AI agents, what we do mostly are simply we have switch statements that handle logic for us when we write code, right? So basically, if I want to do maybe build a small calculator, I would ask the user to give me an input, maybe two numbers to add together, right? Maybe 2 plus 1, right? And then maybe from the input the user gives to us, we already know what kind of functions or what kind of function to call, basically. But I think the agentic workflow is kind of different, right? So there is an interaction, right, between the real world and an LLM, right? So to break this down, right? I think she mentioned something about, LLMs being very intelligent, that the ability to be able to translate text, right? Many things you do, in fact, most of the communication we do today, it's via text, right? Even though we speak, they can still convert them to text, right? So LLMs basically are very, very good at translating those texts, making meaning out of them, just like we process it from our own, just like our brain, basically. So agentic workflow basically leverages on the power of LLMs, right? So it uses that intelligence to basically carry out actions or maybe solve problems that you want it to solve. So what happens is it takes in input from the user. Maybe, for example, still building on the example she gave, I want the weather information in maybe Lagos. Right now, traditionally, what you do is when someone asks you for maybe weather information, you would want to you already have an API ready for you to hit, right, to fetch that weather information and then supply it to the user. But now, what an AI agent will do is, first of all, to reach out to the LLM, right, because that's the first point of contact. You ask the LLM, LLM, what's up? What are we going to do next? Right? LLM will think, okay, this user wants this weather information, right? And then the LLM will look within its tools, the tools that we supply to it, right, and also its memory, right? And then to try to say, oh, okay, this person actually wants weather information. Okay, let me look up within my arsenal and get maybe a weather API, right? And hits that API basically to get that information. Now, once the information is ready, it still goes back to the LLM. The LLM kinds of like process that information, right? And then gives you an output. So basically to summarize this so we don't get deep into what an AI agent is. An AI agent as just a collection of many parts, right? So it has things called tools, it has things called memories, right? It also has things called, the real world data that is not, available to the AI agent at a particular point in time. So what an AI agent does is to utilize the intelligence from an LLM, right? And then use the tools within its disposal to solve the problems that you want it to solve for you. Okay, so there is at the moment, I don't think there is any fully autonomous AI system, right? Such that you go from point A to point B without involvement of maybe a manually written code or maybe a human involvement, right? I think that's super intelligence. That's you're giving complete autonomy to the AI. The AI is able to go from point A to point B without any sort of interaction with any external system. So these are kind of this is the autonomy level for AI agents. Traditionally, like I mentioned earlier on, we had like the code level where every single thing is controlled by we humans. So I will write the code to receive the input. I'll write the code to process that input, and then I'll decide what the output will be based on maybe some predefined set of functions, right? But this is quite different, right? Once an LLM is involved, we move a bit closer to an agentic system, right? So because now an LLM is kind of like that intelligent system that replaces some of the steps that we initially used to do traditionally when we write maybe switch statements and all, right? So if you look at the diagram, you'd see that as we go down, right, more of those human parts that we write ourselves are, getting replaced by AI agents, right? So it's more of like an automation, right? Because these systems, they operate on their own. And that's the actual reason why we have AI agents. Now, it's easy to talk about AI agents, right? But before you even go ahead to decide what kind of AI agents to use, right, you need to understand and you need to know what kind of, the spectra of agents that we have today, right? There's no like predefined way to know, there's no predefined definition or standard to what AI agents are. If you Google AI agents or the types of AI agents, I'm pretty sure you have numerous sources from or different classifications from different sources online today, right? But during our own research, I think we came up with at least two different classifications based on the architecture, right, of the AI agent you're building, and also based on the functions those AI agents perform during, in your product or when you're solving whatever solution you're trying to solve around. Okay, so I think Prisca will take on from here.
So we're talking about classification of AI agents now. There are two like main classifications. AI agents can range from, very lightweight agents, such as maybe text. An example would be something like Grammarly, right? You give it a word and you ask it to, make it professional or something, right? Because you can make mistakes and it will be way better. And it can get to very complicated AI agents like maybe Gemini or even Claude for the software engineers here. So there are different classifications, and we're going to be talking about two main classifications. The first classification is agentic spectrum by architecture. So this is AI agents classified according to how they are built or how they are structured. And the second one is based on functions, but we'll get to that. So this first classifications, right? We have like four main classifications. There's model-based reflex agents, there is goal-based agents, utility-based agents, and learning agents. So Elliot is going to explain the different types of how they are different and how they are built and what you can use them for.
Okay, so if I want to set maybe context as to what exactly we are talking about, right? The spectra of AI agents that is concerned with the architecture of these agents is just talking about how they are built, right? The reason why they are built, not really how they are functioning. Okay, so I think the simplest kind of agents we have are those that just do that just takes an input and there's already a predefined output, right? They are called simple agents. So what happens here is that if you give it X, it already knows that it will do Y for you, right? Remember, the ideal AI agents is basically to automate or to replace the human parts of, the human parts of any system, right? So with that, you don't require a human to be involved, right? So these AI systems are everywhere. These simple reflex AI systems are everywhere. Some of them are the smart thermostats, right? Maybe in your car, for example, if your thermostat is sensing maybe an increment in your engine temperature, it might want to, kind of like regulate that system by maybe increasing the speed, the fan speed in your car, right? That's one example. There are also automated door sensors. If you go to maybe shopping malls and you try to walk in, now there are sensors that are built into an integrated system that kind of tells you that maybe if you walk X distance from the door, let the door open for you. So that's an example of a very simple, it's a simple reflex AI agent. Now we also have goal-based AI agents. Now this is a very common agent. I think I used this today while even coming here because for some reasons the venue was hard to find. Okay, so the goal-based AI agents kind of evaluates what if scenarios. Okay, for Google Maps as an example, what it does is it plans a sequence of actions for you to move or to achieve a particular goal. Now, if you've interacted with Google Maps, what happens is it just tell you that, oh, I want to go to point from point A to point B. But underneath, there is a lot of heavy lifting happening within just that input you're giving to that system to when you arrive at your destination. There's intelligent route searching that happens. It also optimizes for traffic. There's just a lot happening, but it's, all of this underneath are AI systems just acting on behalf of, humans or acting on behalf of, human intelligence. Okay. There's also, the game AI. If you play chess here, you should know of AlphaGo. You should also know of, Stockfish by Leeches. I don't know. Are there any chess fans around here? Okay. So you might be aware of maybe Stockfish and all. But you should know that the goal-based AI agents are basically concerned with moving you or achieving a goal, going from point A to point B. Now, I will rush through this. So there's also the model-based reflex agents. Now, what they do is these agents look at your surroundings, right? They look at your surroundings and then they look for based on the conditions, immediate conditions of your surroundings. They look for the next best action to take for you. Okay, so an example is this Roomba robot we have. Now, I don't know if you've watched maybe some of these adverts. That's why I got to know about this. These robots, they basically move around your house looking for dirty places, to clean, dirty stuff to, declutter and all. So these agents take into account the immediate surrounding. They look at your immediate surrounding, and then they look for the next action to take, right? Don't confuse this with the goal-based model. The goal-based agents that their goal is to take you from point A to point B. That's the intention of those agents. But this particular agent is to optimize for the immediate conditions in a particular environment. Okay. So they make decisions based on history, right? So maybe for example, this Roomba robot can tell that, oh, maybe the kitchen is very dirty. most of the times, or maybe at a certain period of the day. And you might want to optimize, or you might want to say, oh, I think I will dedicate this period of time to always check the kitchen, when maybe there are no people around, right? Or maybe I'm expecting high dirt from this place, at a certain period of time, right? There are other systems like maybe the Nest Learning Thermostat. I think I will need you to Google these out for yourself. Um, then the next one is the utility-based agent. Now, if you look at Tesla Autopilot as an example, right? Okay, I think the best way to explain this is if you're driving and then if you're faced with, let's say, an accident, right? These AI agents are not concerned about other functionalities, right? They are concerned about the best action to take at that particular point in time. So, for example, there are many systems that come with Tesla Autopilot, right? Maybe there are comfort systems, right? There are safety systems that are equipped with all the with this with the Tesla Autopilot. But these systems, right? The AI agents, what they do in these systems is they optimize for the best. They look at the surroundings and then they look for the best actions still to take at a particular point in time, right? So it will optimize for speed, right, when necessary, and it will optimize for safety, right? Maybe in the case where it's expecting like an accident or something, it will prioritize safety over comfort in such scenarios. So these agents choose actions and maximize utility. Of course, there are trade-offs, basically. Then the final classification of AI agents based on architecture is at the learning agent. So uh, your your Netflix recommendation engine is an example of such agents, right? If you keep listening to maybe or watching a particular content, you'd see that your feed most of the times um, would be filled with those kind of content. I think the same thing when you visit a social media website, maybe X. If you're constantly looking at maybe the problems of Nigeria, you go online and then everything you'll be seeing about your feed will be about maybe Boko Haram, might be, there's one, it will be fights here and there, basically. But these systems basically learn based on the inputs the user has been given over time, right? So, I think the next spectra is, by function, right? And Prisca would explain more of this.
Okay. All right. Before I continue, how many of us here like Korean movies? My girlies, how many of us like Korean movies? Oh, okay. So at least we can understand the last example. If you keep watching Korean movies, watch like two. Netflix will start packing them on your feed. So that's just a general example. So the next classification is classification by functions, right? So these ones are categorized based on how they function. So we have text processors, reasoning agents, tool using agents, workflow planners, dialogue agents, research or insight agents, and creative agents. So I'll be explaining these types of agents in depthly. So for text agents, a basic example is Grammarly or even Notion AI, right? If you compose lots of emails, like in your professional setting, you write a lot or the rest, you might be using some of these agents. I know I use it. Maybe if I want to respond to a client and I write it and I feel like, okay, maybe I'm not feeling confident enough to send this, I can put it on Grammarly or even ChatGPT and ask it to rewrite it for me in a professional, way that is maybe empathetic or something, just so that I don't say the wrong things. So that's an example of a text AI agent. They are very fast, they are inexpensive, and they are, reliable. But their cons, limited reasoning, no external action. So you can't ask Grammarly to solve a code for you, or you can't ask it to suggest food meals for you. So they have very limited reasoning. The next type is reasoning agents. These ones are mainly used for structured task classifications and data extractions. Example, ChatGPT, GitHub Copilot, or the rest. So these ones know how to follow instruction. They know how to reason. They know how to think. So example is ChatGPT. So like can ask it, okay, suggest food for me or suggest something for me. I need to reason and then give you suggestions based on the context that you gave it. They have predictable formats and they follow instructions very well. I don't know how many of you guys have explored with ChatGPT, but there are sometimes if I'm querying it or prompting it, I will tell it to, do this first, then do this next, then do this next. And it always does that. So it follows instruction promptly. Now, if those kind of agents still require real data, sometimes they might, mess up. The next type is tool using agents. These ones are mainly used for API calls, search queries, database. An example is GitHub Copilot agents that run commands or tests, Zapier AI agents calling third parties API, ChatGPT with browsing or code executions. So there are sometimes some of these I don't know, like ChatGPT and Claude has it. You can ask them to search the browser, right? They do research. They have their own, don't forget that they are LLMs and they are trained on large amounts of text. So they have some context, but sometimes you want them to make an extra search or go an extra mile to get you something that you need. That's what tool using agents are. So they are grounded in real data and they can perform real actions. For example, taking the extra mile to go look for what you want. An example is you ask ChatGPT the weather. It doesn't have the current weather. So it will definitely have to go and check somewhere to get you the weather information and return it back to you. The next type is workflow planners. So these ones are mainly used for multi-step. So let's take, for example, I think an example of this workflow agent is, I don't know how many of us have visited some websites that have chatbots, right? For their FAQ pages or for their frequently asked questions, right? These chatbots, I believe, are already trained that, if someone comes and asks about pricing, give them this particular type of responses. They ask about maybe setting up an account, give them this particular responses. Those are like step-by-step workflows, right? So you can, that's just a very basic example, right? It can get very complex, right? You can ask it, okay, so if I wake up in the morning, I want you to give me a list of everything I'm supposed to do for that day. And then after you finish suggesting it, set timers, do different steps, right? Those are what this kind of agents are used for. Example, Open AI tasks that plan, act, verify. Replete AI agent for planning, coding, testing fixes. So these ones automate complex workflows, right? They reduce, for something you repeat a lot, they can reduce the time for you. But they can become very complex or very unpredictable, in the sense that maybe if it reaches a particular step in your workflow and then it can't find its way, maybe you didn't add that condition or something, it can just mess up from there. So the next type are dialogue agents. These ones are mainly used for support bots, tutoring, onboarding, conversational flows. Example, Google Assistant, Duolingo AI tutor, ChatGPT conversational mode. I mean, I enjoyed this last one, right, when they just released it, because I think I customized mine to use Pidgin English and be speaking to me. So if I'm asking it questions, it will be replying to me in Pidgin English and it was very fun to try out. I think another very good example is Siri. Lots of us say, "Hey Siri, do this. Hey Siri, do that." That's a conversational AI agent. So they are context aware and they are human-like, right? So users are more likely to get in tune with this kind of agents, but they are harder to control. And of course, there's high user expectations. I can't count how many times I've asked Siri to do something and Siri will be giving me something else, or doing, in fact, it will just be doing something very far from what I asked, then I'll be pissed. So that's my user. I expect, some level of excellence with it, but it can be disappointing. So the next one, we have research or insight agents. These ones are used for information gathering, right? So you can ask it to maybe go and do research on a particular topic. If you're writing your final year project or something, it can do those researches for you. So example, Gemini with search grounding, Perplexity AI, Glean AI for enterprise knowledge. They have strong retrieval plus synthesis, right? So they can analyze large information of text and give you results based on whatever it is you're asking it. But the quality depends on source data, right? So if it's getting its data from something that is not reliable, it will give you unreliable answers, basically. The last but not the least, creative agents. These ones are for my content creators, right? I've used ChatGPT a couple of times, asked it to give me scripts, right? Maybe if I'm shooting a video, if I want to shoot a video, or to even give me video content ideas, right, on what's currently trending. That's an example, right? There's also Adobe Firefly, Midjourney, so it's good for idea generations. Sometimes when I also want to write articles, it will give me a list of topics that I can write on based on my profession. So we'll be moving into the next step. I think is like the main reason why we brought this talk today. Decision metrics. Like if you're trying to build a product or you don't even have to build a product, you're trying to maybe use AI more to automate lots of things. What kind of questions are you going to ask, right? Because like I explained, You can't tell me you want to go to New Heaven and you'll be using a jet or an aeroplane. That's just the basic explanation. So they are simple. Like if your task requires something simple, you use a simple AI agent. If it requires something more complex, you use a complex AI agent. So I'll be handing over to Elliot to explain some of these decision metrics for us.
Okay, so we have less time than planned for, so I'll just kind of breeze through some of the decisions. But before you even go ahead to use an AI agent, you need to ask yourself some important questions. Do I really need an AI agent? There's a buzz around the AI agents. Many products, they just want to integrate it because, every company is doing it, but it's not really ideal because you could lead to more bugs in your system. You could be spending more money than necessary. Basically, before you even go ahead to use an AI agent, the important thing you need to ask yourself is if you really need an AI agent in your product. That's before you go ahead. I don't know if you have actually built maybe an AI agent or maybe worked with an AI agent here before. Okay, nice, nice. So which AI agent did you? uh, Game flow, drink flow. Okay, was it useful? Oh, okay, nice. Okay, so before you go ahead to even integrate any AI agent into your system, yeah, some questions you need to ask is, what's the core task? Do you need real time data? Right? Do you need what are you trying to transform text? Are you doing some classification? So the first thing you'd ask, right, is what am I trying to solve? What problem am I trying to solve? And is this thing, can I build it even without or can I build this without an AI involved? Remember, the goal of an AI is to automate your task, right? To make the task easier and continuous, right? Without any human interaction in the process. Now, other questions you will need to ask is, does it require maybe external factual data? I think that's similar to the previous one. To if you need, I think yes, these AI LLMs are trained based on data, but sometimes they are outdated, right? So, if you're using an AI agent, some questions you want to ask is if I really need to get information from an external source, right? Do I need an API, maybe a weather API to get this data, right? Because some content, definitely, you need to be in current, you need to have current data for you to get the right answers to, the problems you're trying to solve. Do I need to take real actions? Like maybe make API calls, still these are questions. Is the task a multi-step task? Like, I think one of the agents we talked about is the planner agent where you're able to do many things, right? You're able to orchestrate many things at once. So maybe there are many AI systems involved. So you're going from one AI agent to another AI agent that do different kind of tasks altogether. Now, the next, I'll just go through this. I'm not explaining much because of the time. Now, is it a conversational UX, right? Do you need, for example, the chatbots in your product to ask about maybe the knowledge, like a knowledge base or something in your product, to help the user navigate your product better, right? You might want to consider maybe a dialogue agent for this. What are the reliability requirements, right? Do you need flexibility when making decisions? Then you know that you need reasoning agents, right? In such scenarios where maybe you need to make you need to decide between different systems, like maybe the case of maybe the Tesla autopilot, where you need to prioritize maybe a particular system over another system at a certain point during your workflow. Now you want to consider maybe a reasoning agent. Now, is there delay? Do you need delay before you get the data, or before you go from uh, the the questions phase to the final output, or the solution phase, right? Do you need, is there going to be, would there be delay before you get that data, right? So these are questions rather that you need to ask yourself, because for systems that you have maybe an AI doing many things at once, right? Maybe it needs to go for fetch data from this source, fetch data from this other source, multiple sources, and then do an analysis on that data before it gives you an output. Then you know that there will be latency when it comes to data transfer from the point where the user, where you give it an input to the point where there is an output. And then I think which I feel is like the most important one, could a simpler solution work? Right? Do you really need an AI agent? Okay. So I think our time is up basically. So I'll just wrap everything up at once. So there are common mistakes that we do or we make when we're deciding on AI agents. One of them is we over engineer the entire system itself. So instead of picking a simpler agent to solve our problem, we end up picking maybe something that would cost us more money, or maybe even cost us a lot to set up. and then we kind of like ignore the total cost when we're looking for an AI agent to basically use to solve or automate any part of our system. Now, not having enough data, right? If choosing learning agents, for example, choosing learning agents without sufficient quality training data. So AI agents from time to time, LLMs actually need to, they need to be updated. Their knowledge needs to be updated. So if you don't know, if you, for example, you choose maybe a tool agent over a learning agent, right? In such scenario, you're doing yourself a disservice because for a system that you require to continually learn, right? In that case, it means that you keep going back to retrain your LLM, just to make sure that you meet up with the demands of the system itself. So, what are the takeaways? Now, LLMs basically, right? If there's anything I want you to pick up from the talk, LLMs are, they are basically the brains behind some of these autonomous systems that we interact with. Okay, so also know that these AI agents, they have, besides the LLM, they have a lot of tools they work with. Right, these tools are just there to make the work easier. Remember, the brain, the intelligence is the LLM. The AI agents are just like orchestrators, right? They reach out to the LLM when necessary, and then the LLMs communicate with the tools and its memory to make sure that, it gives you or it solves the problem that you want. Now, simplicity always wins. So start small and scale up when necessary. So, thank you everyone for listening. It was nice having this talk.